Ladies, gentlemen, and none of the above, welcome back. Today we are testing a power supply. And this is a 12 volt 3 amp power supply that I want to use for one of our products. And I need to know if it's any good. I would like to show you what I actually look for in testing a power supply like this. So let's get started. As you can see, instead of plugging it in a wall, I have these weird looking connectors that hook up to my variac, and this is what a variac is. It's essentially a transformer that you can turn up and down. Over here there's a display. You can see the voltage, you can see the current, and the power consumption and the power factor. So let's first of all look at when does it switch on. The input here is rated at 100 to 240 volts AC. So let's see at which voltage does it switch. And I can check that by looking at this device over here that I've connected to the power supply through the connector, like so. And it will show us how much volts it puts out, and we can load the power supply. And by loading the power supply, we can know exactly how much output power it gives. And by looking at the power meter over here, we can see how much power it consumes. And with that, we can calculate the efficiency. So let's get started. Oh, there we go, 12.2 at 108 volts. If I turn it back a little bit, it stays. Okay. Now, let's see. Let's put some load on it. It should be able to do 3 amps, so that's what I'm going to ask for. Yes, at 81 volts, it gives 11.96 volts at 3 amps. Now I'm going to ramp her up to 220, which is the most commonly used voltage. There we go, 220. Power consumption is the same, output voltage and amperage is also the same. And then I'm going to turn it up a little bit more, 240, to see if anything happens there. Nope, it's okay. Power consumption stays equal, and output voltage and output current is also equal. Okay, I'm going to rev it back to 220 right now and have a look at the ripple on the output. Now the ripple works as follows. This is a switch mode power supply. So basically it takes the AC power in, rectifies it, let it go through MOSFET, switches it, and lets it go through a transformer, rectifies it again, and then you have a DC output. That's the basics of a switch mode power supply. Because it switches on and off, they always have a little bit of ripple. And it's interesting to know how much, because it tells you something about the quality of the power supply. To do this, we look at the oscilloscope over here. And looking at the oscilloscope, I can see that there is about 690 to 700 millivolts worth of ripple. Now, if I want to have that slightly more accurate, I can do it manually. Starts here, stops there, and then we're looking at about 680 millivolts. As you can see over here, delta Y1. That's quite a lot of ripple. So, the question is, why is that? Now, of course, this is at peak load, 3 amps, but I will be using this device at 3 amps, so it's important that it doesn't have that much ripple on the output. Now, for us to check at what the frequency of that actual switching signal is, I am going to have a look at that. And we're looking at about 62 kilohertz. And that kind of makes sense, because normally these switch mode power supplies, they switch between, say, 40 and 80 kilohertz or so. In general, there's exceptions, but for these wall boards, that's pretty much the standard. Now I'm going to have to find out why this ripple is there, so I'm going to pull the device apart and I'm going to have a little peek at the inside. Alright, so no screws. This is a ultrasonically welded housing, which means they have 2 plastic parts that mate in the middle over here, and they use 20 to 40 kilohertz of ultrasonic vibration to melt the plastic and let it stick together. That means I'm going to have to get physical on this one, which I will. I have here a hammer and a screwdriver, and I'm going to pinch it here in the corners to see if I can break it loose. Here we go. Twist it. Normally if you take the four corners you can get her to come apart, but as you know, that will be the last time. No screws means you can't put it back together again. There we go. Ta-da! That's the circuit board on the inside, and this is the other side of it. So, whilst it's open, I think we might as well have a little look at the quality of the components used. First of all, the PCB board. The PCB board is made of FR1, which is the cheapest material you can get, single-sided, and it's essentially just paper and glue. Not the greatest material, but very common in low-cost power supplies. When we go to the other side, we can see here that we have 220 input, or AC high voltage input, and then we have a capacitor over here, that's the main buffer capacitor, and we have a common mode choke that actually is supposed to filter out any residual noise and prevent it from going into the net, so that you have some reception on your shortwave radio. This is a bridge rectifier, so in bridge rectifier, high voltage capacitor, which is, let's have a look, 400 volts, 22 microfarads, into another high voltage capacitor, which is the same value here. No, 220 microfarads, 22 microfarads, 400 volts. So yep, they are the same value. Oddly enough, they have a different height, even though the value is exactly the same. That's kind of weird, but okay. This is the main switching MOSFET that switches this thing, which is the transformer. The transformer itself looks relatively good. Windings look thick enough. There's insulation on the inside. Core material looks okay. Then we can go to the other side. On the other side, this is the main rectifying diode over here. That's on the heatsink. Then we have the output capacitors rated 25 volts, 1000 microfarads. And two of those, so 2000 microfarads on the output, plus a choke to prevent the noise from escaping, but as we have noticed, the escaping noise is still quite prevalent. So the question is the ESR on these capacitors low enough, and can we check that to see what the quality is of these capacitors? If the quality is not good enough, then we can ask the manufacturer to change for a better brand, because looking at these things, they're pretty much no-name, low-cost capacitors. I mean, I've never heard of KSJ capacitors, and I've been in China for quite a while, so that does tell you something. I think that's it for right now. I'm going to change some parts and have a look, and then we can try and test it one more time to see if we can change the results. Well then, ladies and gentlemen, having looked at this design, we will have to conclude that this is not quite good enough for what we want. Its components, especially the capacitors, which are the ones that normally go first, are of low quality, and overall we will have to find something better than this. And I think we have already done that. Actually, we found a quite nice meanwhile power supply, which is going to be a lot better than this one. Okay, thank you very much. Until next time.